next problem is called first missing positive. We are given an unsorted integer array called nums, and we have to return the smallest missing positive integer. We have to implement an algorithm that runs in linear time, and we cannot create any additional space, so our space complexity should be constant. Now, for the first example, we have the array 1, 2, and 0, and the first positive number, because we have 1 and 2, the first positive number that's missing is actually 3, which we return uh, as the output of the function. Now, in the second example, we also see that we have negative numbers, but we can basically just, they are not of interest for us, so we can basically just skip them. Now we have 1, 3, 4. So between 1 and 3, of course, 2 is missing. So that's the first positive number that's missing. 1 is in the array, 2 is not, so we return 2. Now for the third example, we have almost a sequence. The number that's missing here is 10, but we are not interested in that number. We're interested in the first number that's positive and that's missing. In this case, it's basically 1, because we don't have 1, 2, 3, but the 1 is the first and the smallest one, so we return 1 as the result of the function. Now, for the length of the array that's given to us by the problem statement, it ranges from 1 to 10 to the 5th, and the distribution of the numbers inside that array are ranging from the minimum and to the maximum integer. Now, there are a few tricks that we have learned so far during the easy and medium questions, and there were some similar questions to this. There is that one trick that we used where we marked the corresponding index for a number. So for example, if we have number 3, we would mark the corresponding index, and we will get the index by just reducing the number by 1. So in this case, it would be 2, and we would mark the element at the index 2 by either making it negative or basically just adding the length of the array to it, and so on. Problem is that we have negative numbers, but negative numbers are really not of our interest here. So we can basically just in some way discard them, in some way mask them. So that's the first problem that we're going to solve. And to solve that problem, we will basically iterate over the array, and we will find the first positive number. And if there's no positive number, then we know that the first missing positive number will be 1. So we can return early from the function. But in this case, when we start iterating from the start of the array, we will see that the first positive number is 3. So our first operation will be transforming the initial array to the following array. So we will, if the number is positive, we will just copy it over. But if it's negative, we'll transform it to the first positive number, which in our case is 3. So that's the first, we solved basically the first problem, because these two numbers now, all the negative numbers will basically point to the index that corresponds to the first positive number that we found. And we can allow that because we will be only changing the sign of the element at the corresponding index once. And that basically brings us to our second step. We have to mark that the element exists inside the array. And we will do that by marking the corresponding element at the corresponding index by making it negative. So for example, our second transformation is that we will traverse through the array, and we will find the corresponding index, and we will mask that the number exists by making that element at the corresponding index negative. So our first number is 3, and we will basically just make the first the index that matches the number 3, which in our case is 2. So we will just make a number at that position negative. So we'll make 3, and I will just copy over all the numbers. Our second number is 4, and the index that corresponds to that number is 3. So we'll just make that number negative. Next, we move to the number 3, but now it's not 3, it's -3, but we can always use the absolute value. And because it points to itself and the number is already negative, we will not do anything. We already know that the number 3 is appearing in the air because we marked the corresponding index element of the corresponding index negative. And the last number that is number 1 And in this case, we already transform it, but we'll use the absolute value, and we will map it to 0, and we will make the element at the index 0 negative. Now, when we traverse the array, again, the transformed array, we will start from the first element, of course, and we will basically search for the first positive number. Once we find the first positive number, we will do the inverse transformation to find the corresponding element that is missing, because we have never have never found it, and we never marked its corresponding index to negative. So in this case, the first positive number is 4. It matches the index 1, and we basically do 1 plus 1 to find the element that's missing. And in this case, it's number 2. So number 2 is the first element, the first positive element that's missing. And if we go back to our array, we see that we have 1, we have 3 and 4, but 2 is missing. Now, it's important to know that we can have elements that map to an index that is outside of our array. So, for example, if we have 100, it would map to index 99, which is out of boundary here. So we have to be careful when operating on numbers that correspond to the index that's out of boundary for our array. But for this problem, it doesn't really matter, because we are searching for the first positive number. And if we have all, for example, if we have a sequence 100, 101, and 102, we will not map it to any of the of the indices. And when we traverse, the first positive number in the last step will be 100. And we know that element is at the index 0, so the corresponding element is 1. And the number 1 is the first missing positive number. And we can have an array of, for example, length 3, where you have 1, 2, 3. So all the elements from 1 to 3 are there. Basically, the next positive element that is missing will be the element that's the length of the array plus 1. So in this case, it will be number 4. And the last step, the last thing that we can have, the last scenario is, for example, if we have 1, 2, and then 100, for example. So 100 will not point to anywhere, and 1 and 2 will point to the first and the second number, so we will know that 1, 2 exists. The 100 will be first positive number, and it will match to in our last step, it will match to the index 2, and when we use this index to find the number it's missing, it will be 2 plus 1, which is equal to 3, and we know that the first positive number that's missing is number 3. Now, because we are only traversing through array several times, we have the time complexity equal to linear to the length of the array. And for the space complexity, because we are operating in place on the same array, we have constant space complexity, which is required by the problem statement. So we'll start by declaring n as the length of the array, and our first positive will be marked as 0. We will first traverse through the whole array in order to find the first positive number. And we will use that first positive number first determine if we have any, and if we don't have, we will just return 1, because that's our first positive number if all the numbers in the input array are negative. If not, we will mark every single negative number in the input array as the first positive number that we have found. So basically, we are discarding the negative numbers. Next, we will traverse through the array again, and we will use the absolute value to find the matching index if it's in boundary of the input array. And when we find the corresponding index, we will turn the element at that index negative. That will serve as a mask to know that we have found the corresponding element. So if we mask the element in the index 2, we know that somewhere in the array we have found element 3. And basically, our last check is to traverse the array and see what's the first positive element. And that first positive element, it's at the index that corresponds to the first missing positive number. So we will just use that index plus 1 to return that number. If, however, we don't return from this for loop, we know that all the numbers ranging from 1 to n, where n is the length of the array, have been found inside the array. So basically, we can just return the next element, which we do by just incrementing the length of the array by 1.